What's up?
I thought we were supposed to do power 1 of the fire. How is Dino? Oh! Because Dino's straight to the fire. Whoops. Sorry.
As I say, that's why it's one of those things that the drawing of the picture really does make a big difference. Because a lot of times the mistake that we made would be like, oh, tower 1 is with this 27 degrees, and so we'd use this guy. So that is a very, very common mistake. So just be really, really careful, okay? Let's try one more on these, and then we'll finish the rest of them up tomorrow. So we've got a surveyor that has the direction from point A to point B is south 63 west. And the direction from C to point C from point A is south 38 degrees west. So we're starting at point A on both times. So I'm going to put my point A up here. So from point A to point B is, is south 63 to the west. So we never eat soggy waffles, so we're westing this way. 63 degrees means we're going to be pretty far over like this. So 63 down here. So this guy is B. Okay. The next one is worded weird. The direction to point C from point A. So we're still starting at point A. We're going to go south 38 west. So again, never eat soggy waffles. We're going the same kind of direction. But this time we're only going 38 degrees, which I know I'm very off on that angle. Maybe that's slightly less. This guy. So this guy is 38 degrees to get to point C.
What if we don't put C on like the other side of A? Like is A the dot? Yeah.
A is this black dot. Yes. A is this black dot up here. I was just leaving us a little space. So this guy's A. And because it is south and west, they're both south and west. So that's why they're in the same kind of quadrant.
So when we say a point is like south and west, we're only in the southwest realm, unless it tells us otherwise? Okay.
Well, and it was just because we got our two different directions, our two different points. And then they also give us a couple of distances. They say the distance from A to B is 239 yards. And from B to C is 374 yards. So we're trying to figure out the distance from A to C. So this is the guy we want. What is our instinct on this?
Do we have to do something with like the opposite interior angles or something with the 38? What do we do with that? Why is it on the outside?
Well, because that is a bearing, it came from the center here. So it comes off of our south. It's going to be really helpful, honestly, when we're looking for this angle here.
So do we just subtract 38 from 63?
Other way, but yes. Yeah, because if we want to find this angle inside our triangle, I know that this guy is 63 from this black line, and I know this guy's 38 from that black line, so the difference between them is going to be what? This, this angle in here, I'm going to call it alpha. inside our triangle is going to be that 63 minus that 38. Our alpha is the blue 63 degrees minus that green 38 degrees. So angle alpha measures 25 degrees. That was just changing our colors here. And our green 38, just so we match the colors so we can see where those came from. So now I know this angle. I was gonna say we've got a whole lot of information, right?
Or no, sorry. 239 C. That's C's side.
Yeah. So what are we gonna need to find first?
Angle C.
We're gonna need to find angle C. We need to find out what gamma is. How can I find out what gamma is? Mm-hmm.
Sine of C over 239.
Mm-hmm. Because this guy's our gamma. So we have sine of gamma over our 239 is going to equal what?
Sine of 25 over 374.
Mm-hmm. Our sine of 25, that's our alpha. 25 degrees over that 3, yeah, the 374. Because I know this relationship and I know this dimension. With the beta and the D, I don't know any of those pieces, so we need to figure out something that we do know. So we're going to need to solve this. So we're going to have our sine of gamma. Why is it so small?
No.
Oh, the number?
Yeah.
Yes. We have our 239. We multiply on both sides.
Oh, don't we still have to find the sine of that?
Sine of 25 degrees is 374. But that's sine of gamma. How do I get the inverse sine? We'll do arc sine or the inverse of sine. So we're doing arc sine of that fraction. It's a mess, but it's a thing. 239 sine of 25 degrees over 374. So we're doing the inverse here. Remember, inverse and reciprocal are not the same thing. So what do we get for gamma? 2 decimal places.
15.67.
15.67 degrees. So this guy is 15.67 degrees. If I know gamma and I know alpha, what's beta gonna be? What is our third angle in here? Oh, wrong color. Mm-hmm. Mm-hmm. Yeah, this is going to be 139.33 degrees. So our last piece, and this is our last bit for today, we need to find that distance. How are we going to set that up? Building up a little barrier here because I'm running out of space because they were too big. How are we going to set up our relationship trying to find side D? Mm-hmm.
Equal to.
I'm gonna give us a little bit more space, but it's gonna make these a little small.
374 over sine 25.
Mm-hmm. Yeah. 374 over sine of 25. So it's gonna be gross and it's gonna be kind of decimally, but we can do this. Multiply both sides by our sine of 139.33. So we get that this distance is our, ooh.
576.73.
Mhm. So our distance is gonna be 576, you said 0.73? Just because I rounded differently in my notes, and that's okay. 0.73, and our unit is in yards. Okay? So that's the distance we were looking for here. Okay? We will work with the rest of those story problems tomorrow. So, like, the rest of those questions we'll do tomorrow. I just wasn't going to, like, pre-cut them because I never really know where we're going to transition.
Is there any way we can just practice setting up? Like, it's not even like
The calculation.
It's not even the calculations, it's just setting
It's
up.
the reading of the story. Yeah. And the finding of the pieces. That's part of the reason we've got a couple more to practice, is so we can practice building the picture. I do have on the Canvas page a couple of videos linked. We're going to talk it through tomorrow, and I'll have a physical representation of what the videos talk about. But there's some good animations in there talking about what we're going to do after we finish the story problems tomorrow. So if you want to watch them beforehand, they're linked in the Canvas page. If you want to wait and watch them afterwards, that's okay too. There's just a couple of good animations in there about one of the limitations of the law of sines. Okay, so I've got both videos linked on the Canvas page, but I'll talk them through tomorrow too. And I'll see you tomorrow. Have a great rest of your day. Happy Monday. 2 weeks left of spring break. 2 weeks left. We can do this.